Today we're going to look at chapter 4.7, the stoichiometry of precipitation reactions. So in a precipitation reaction, you have two solutions that combine and form a precipitant. And you are going to have the volume and molarity of the solutions, and you'll need that information in your stoichiometry calculations. And we'll do also a problem where we have to determine the limiting reactant. So the first thing we need to do is write the balanced chemical equation. So sodium chromate plus silver nitrate will react to form silver chromate, which is our precipitant, and sodium nitrate. I need to balance this equation, and I do that by putting a 2 in front of the sodium nitrate and a 2 in front of the silver nitrate. And so the question is asking what mass of sodium chromate is required to precipitate all the silver ions from 75 milliliters of a 0.100 molar solution of silver nitrate. So I'm going to start with my volume of my silver nitrate. So if kind of like think about this, I'm going to convert these two to moles. Whoops. I'm going to convert to moles of silver chromate. I'm going to convert over to moles of silver nitrate. I'm going to convert to moles of sodium chromate and then to grams. Is kind of my pathway I'm going to use. So 75 milliliters of silver nitrate It does not like me writing this line. There we go. Silver nitrate. And I'm going to convert from milliliters of silver nitrate to liters of silver nitrate. Once I have liters of silver nitrate, I can use the molarity of silver nitrate to convert to moles of silver nitrate. So then I've used this here to convert to moles. Now I'm going to go over my mole tunnel, use my mole ratio for my balanced chemical equation, and convert from moles of silver nitrate to moles of sodium chromate. So then if I look back at my little flow chart I made, now I'm here at moles. So then I'm going to convert to the molar mass of sodium chromate with one more step, and then we'll go put in all of our numbers. So going back and filling in my numbers, I would have a plate, or I would go from milliliters to liters. 1 liter is 1,000 milliliters. The molarity was given to us. 1 liter of silver nitrate is 0.100 moles. The mole ratios from the balanced chemical equation: 2 moles of silver nitrate react with 1 mole of sodium chromate. And then I need to calculate the molar mass of sodium chromate. And so I have sodium, 2 of them. I have chromate in 1 of those, and I have 4 oxygens. Sodium is 22.99. Chromate is 52.00. Oxygen is 16. Add those together, I get 161.98 grams per mole. So then when you look at this whole problem, and maybe I will make it a little smaller so we can see it all on one page. When you look at this whole problem, units cancel diagonally. So milliliters cancel, liters cancel, moles cancel, so that you're left with the units you want, which are grams of sodium chromate, and you will get, multiply the top, multiply the bottom, need 3 sig figs. You're going to get 0.607 grams of sodium chromate. Okay, we'll go to our next problem. And so our next problem is a limiting reactant problem. You don't have to do all of the how much in excess, how much of, or what's the percent yield, but we're going to have to figure out what reactant is our limiting reactant. So the problem says, what mass of iron 3 hydroxide precipitant can be produced by reacting 75.0 milliliters of a 0.105 molar iron 3 nitrate solution with 125 milliliters of 0.150 molar sodium hydroxide. So again, you first have to write your balanced equation. And so you're going to have iron 3 nitrate solution reacting, that's our precipitant. I have that on the wrong side. You have iron 3 nitrate reacting with sodium hydroxide. And that's going to produce iron 3 hydroxide and sodium nitrate. Now you do need to balance this equation. You have 3 nitrates on the reactant side, so I need to put a 3 here in front of sodium nitrate. That gives me 3 sodiums. I also have 3 hydroxides on the product side, so I need to put a 3 here in front of sodium hydroxide. And so the question asks, what mass of iron 3 hydroxide, so what mass of this will precipitate if you have so I'm just going to put an H for have. It is not letting me write. There we go. Okay, I can actually fit it in there. If I have a 75 milliliters of a 0.105 molar solution of iron 3 nitrate and 125 milliliters of a 0.150 molar sodium hydroxide solution. Now those are both in volume, your volume and your molarity. What you need to do for both of these is convert them to moles. How many moles do we have of each of those? So we'll start with the iron 3 nitrate. I have 75 milliliters. It does not like it when I get close to the edge. There we go. 75.0 milliliters of iron 3 nitrate. To be able to work with the molarity, I need to convert from milliliters of iron 3 nitrate to liters of iron 3 nitrate. And then from liters of iron 3 nitrate to moles. And so 1 liter is 1,000 milliliters. We know that the molarity of the iron 3 nitrate was 0.105 moles per 1 liter. So when you do that calculation, you will get 0.00788 moles of iron 3 nitrate. And then we're going to do the same thing with the sodium hydroxide, convert that to moles. So I have 125 milliliters of sodium hydroxide. I'm going to convert from milliliters of sodium hydroxide to liters of sodium hydroxide, from liters of sodium hydroxide to moles of sodium hydroxide. 1 liter is 1,000 milliliters. This was a 0.150 molar solution of sodium hydroxide. So when I do that calculation, I have 0.0 188 moles of sodium hydroxide. So the next step is to figure out, well, what do I need? So I would convert this to moles of sodium hydroxide and this to moles of iron 3 nitrate. So if I have 0.00788 moles of iron 3 nitrate, I'm going to go from moles of iron 3 nitrate to moles of sodium hydroxide. And if you go back up to the balanced chemical equation, it's a 1:3 ratio. 1 mole of iron 3 nitrate forms 3 moles of sodium hydroxide. And so you would get 0.0236 moles of sodium hydroxide. And you can see when we subtract this, we don't have enough sodium hydroxide. So the sodium hydroxides are a limiting reactant, but I'm still going to double check. I'm going to convert from what I have in moles of sodium hydroxide, and I'm going to convert that to moles of iron 3 nitrate. And so I have 1 mole of iron 3 nitrate reacting with 3 moles of sodium hydroxide. And so I would have 0.00627 moles of iron 3 nitrate. And so you can see I have excess of the iron 3 nitrate. And so to figure out how many grams of iron 3 hydroxide, it's based off the limiting reactant. This is limiting. And so I'm going to convert from moles of sodium hydroxide to moles of my precipitant to grams of my precipitant. So I'm going to convert from 0.0188 moles of sodium hydroxide, my limiting reactant, to moles of iron 3 hydroxide to grams of iron 3 hydroxide. I'll do that at the bottom. So I'm going to take my limiting reactant amount in moles, use the mole ratio from the balanced chemical equation to convert from moles of sodium hydroxide to moles of iron 3 hydroxide. And then I will use the molar mass of iron 3 hydroxide to convert to grams. So moles of iron 3 hydroxide if I go back up to the balanced chemical equation, 1 mole of iron 3 hydroxide forms from 3 moles of sodium hydroxide. We'll calculate the molar mass of iron 3 hydroxide. I have 1 iron, 3 oxygens, 3 hydrogens. Iron's molar mass is 55.85. Oxygen's mass is 16. Hydrogen is 1.008. When I add those together, I get 106.87. So I'll go back up to my equation here. 1 mole is 106.87 grams. And so I'll change the view so we can see the whole problem. You can see the whole problem there. Multiply the top, multiply the bottom, round for the correct number of sig figs. And you get 0.670 grams of iron 3 hydroxide. So you'll have some problems to do to practice and turn in through the Google Drive assignment. If you have any questions, please send me a message in Schoology.